Okay, so these are our 1.2.3 notes, which are all about being able to work with both parallel and perpendicular lines. To start, let's do some quick review of our learning targets 1.2.1 and 1.2.2. So for today, let's say you have a problem that says, convert the following from standard form to slope intercept form, and then graph the linear function you created. So we are converting from standard to slope-intercept form, and our function we're using is 6x plus 3y equals 12. So our goal, convert from standard form, which is ax plus by equals c, to slope-intercept form, which is y equals mx plus b, and then to graph it. So slope-intercept form, remember, y equals mx plus b. So to convert to slope-intercept form, we want to get y by itself. So let's start by doing that. So that means we need to get rid of this 6x. So we cancel a positive 6x with a negative 6x. That gives us 3y and 12 minus 6x. So not like terms because one has an x and another doesn't. So this does not combine to like 6 or anything. So we just got negative 6x plus 12. Last thing we got to do to get y alone is get rid of that multiplier. Cancel multiplication with division. So you've got y equals negative 6 over 3 is negative 2. 12 over 3 is 4. So we've done the first part. We've converted the slope-intercept form. Y equals mx plus b. Now let's graph it. So when we're graphing here, we'll just go by, just put 5 tick marks in here. To start, I'll add more if I need them. So when we're graphing, we start with our y-intercept. So our y-intercept is 4, so let's start there. We have a slope of negative 2. So we have m is negative 2, b is 4. So if our slope's negative 2, that means our rise is negative 2, our run is 1. Negative 2 over 1. So we're going down 1, 2, over 1. Down 1, 1, 2, over 1. Down 1, 2, over 1. Down 1, 2, over 1. And there we have it. There's our linear function. Okay, so there's our review. Let's get into some new stuff. So we're focusing on parallel and perpendicular lines. So let's define parallel lines first. So parallel lines are, number one, they're lines that don't intersect. They're lines that don't intersect. And number two, that means they are lines that have the same slope, the same m value. So let's consider 3 different functions. So we have y equals 2x plus 3, y equals 2x plus 1, and y equals 2x minus 5. So you'll notice these all have the same m value. They all have the same slope. And as we graph here, let's graph each of these. So we'll start with 2x plus 3. So we've got that y-intercept at 3 and a slope of 2. So that means we go up 2 over 1, up 2 over 1. And the same would be true in the opposite direction, down 2 over 1, down 2 over 1, and we'll go one more, down 2 over 1. So there's our first line, y equals 2x plus 3. So number 2 here, we'll do y equals 2x plus 1. So we have our y-intercept at 1, we go up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. So obviously my graph's not perfect, but you can see these are two parallel lines. They're not going to intersect, and they do have the same slope. And we could do one more. We've got negative 5 as our y-intercept, so 1, 2, 3, 4, 5. Slope of 2, so we go up 2 over 1, up 2 over 1, up 2 over 1. And you can see the trend here. So whenever you have parallel lines, whenever you have lines with the same slope, they will never intersect. So let's say you are given the function y equals 3x plus 1. And you want to create three parallel functions. Okay, so we're just creating three functions here. Oh, you can't see, sorry. So we have given the function y equals 3x plus 1, create three parallel functions. So go ahead and try that on your own. Pause the video. Okay, so we know parallel functions have the same slope. So you could have y equals 3x plus 4, y equals 3x minus 7, y equals 3x plus 1,000 over 100 over 3. The y-intercept doesn't matter. As long as you have the same slope, you'll have a parallel function. Okay. All right, so our next problem, and I'm going to put a star next to this because this is an important one for us. So let's say a linear function is parallel to the line y equals 3x minus 4, and also goes through the point 321. What is the linear equation parallel, or sorry, what is the linear equation, my bad, for this function? Okay, so we have a linear function that is parallel to y equals 3x minus 4, and it goes through the point 321. What is the linear equation for this function? So we want to write a linear equation, so that means we're probably going to be using slope-intercept form, y equals mx plus b. So we're creating a new equation, so that means we need an m and we need a b. So from this problem, we're told the linear function is parallel to this line. So if it's parallel, that means the slope has to be the same. So as we look at the line it's parallel to, y equals 3x minus 4, we can find the slope of this line. It's whatever's attached to x, so in this case 3. And if our line is parallel, that means it's got to have the same slope. So it has to have a slope of 3. So at this point, we have y equals 3x plus b. So we still need that b value. The other piece of information we're given is the point 321. So this line has a slope of 3, and it's going to go through the point 321. So this is a point that's on the line, or a solution to the equation. So with that in mind, this point it's an x and a y value. 3 is x, 21 is y. So what we can do is we can plug in 3 for x and 21 for y into this equation. So we have 21 equals 9 plus b. And now it's just a one-step equation. Subtract 9 from both sides. 21 minus 9 is 12, so we get b equals 12. So we have m, we have b, so we just plug those back into slope-intercept form. We get y equals 3x plus 12. So there's the equation of a line that's parallel to 3x minus 4 and goes through 321. Okay. Next, we need to talk about perpendicular lines. Perpendicular lines. So, perpendicular lines, so graphically, they intersect at a right angle. Remember, a right angle is 90 degrees. In terms of their equation, they have a negative reciprocal slope. Negative reciprocal slope. What a negative reciprocal slope means is if you're given a number, you flip the fraction and you change the sign. So as an example, two perpendicular lines would be y equals 2 over 3x plus 1, and y equals, so the negative reciprocal of that would be, you'd flip the fraction, so it'd be 3 over 2, and you change the sign, so it goes from positive to negative. So negative 3 over 2x plus 4. So if I were to graph these two functions, so graphing the first, we have a point at 0, 1, that's our y-intercept, and then a slope of 2 over 3. So we go up 2 over 1, 2, 3, up 2 over 1, 2, 3. And then the same in the opposite direction, down 2 over 1, 2, 3, down 2 over 1, 2, 3. Do your best with that. And then we have a point at 4, 1, 2, 3, 4. And negative 3 over 2, so we go down 1, 2, 3 over 1, 2. Down 1, 2, 3 over 1, 2. And obviously it's not perfect, but it looks pretty close. It looks like we might have a right angle there. So those are perpendicular lines. So we're going to do the same type of a problem that we did with parallel. So this is, again, what I would consider a very important example, one you want to note. So our problem here is convert the following from standard form to slope-intercept form. And then graph the linear. Oops, what am I doing? I'm doing the wrong problem. Sorry, ignore that. This is what we'll do first. Okay, so we'll continue with perpendicular lines. we want to, let's start here by just identifying the negative reciprocal of the following numbers. So 2/5, 4, -5, -3/4, and 1. So I'd like you to identify the negative reciprocal for those 5 numbers. So pause the video, take a moment and do that. Okay, so for number 1, negative reciprocal, so it's positive, so it's got to switch to negative, and then you flip the fraction, it'll be 5/2. Number 2, it's positive, so it's got to switch to negative, and then you flip the fraction as well, so it's 4. You could think about it as 4/1, so it'd become 1/4. Number 3, you have -5, so this has got to switch to positive, and then flip the fraction, it becomes 1/5. Here, another negative switches to positive, flip the fraction. 1 switches to negative, and this is 1/1. So if you flip 1/1, it's still 1/1, or just 1. Okay. All right. Let's do something else. Create 3 equations perpendicular to y equals -2/3 x plus 5. 3 equations perpendicular to y equals -2/3 x plus 5. Pause it, go for it. Okay, so negative, if it's got to be perpendicular, that means our m has to be the negative reciprocal. So again, change the sign so it'll become positive, and then flip the fraction, so it's 3/2. Beyond that, doesn't matter what your y-intercept is. You could have no y-intercept or a 0 y-intercept. Doesn't really matter. As long as that slope is 3/2, you're all set. Okay. All right. This is our last problem here. This is the one you want to star. You want to make sure you especially have down. Okay. So a linear function goes through the point -1,7, and also is perpendicular to the line y equals 1/2 x minus 6. What's the linear equation of this function? So we have a linear function that goes through a point, so it goes through the point -1,7. It's also perpendicular to the line y equals 1/2 x minus 6. What is the linear equation of this function? So we're writing a linear equation again. So y equals mx plus b is where it's at. So we need m and we need b. So if our equation is perpendicular, that means the slope has to be the negative reciprocal of this line. So this line's slope is 1/2. Our slope would have to be the negative, so opposite sign, and then reciprocal. So 2/1, or just 2. So that'll give us y equals -2x plus b if we just plug m in. Now we need b. We're given a point again, so we can plug in that point for x and y to solve for b. So let's plug in -1 for x and 7 for y and solve for b. So -2 times -1 is +2 plus b. Lastly, to get this b alone, we need to subtract 2 from both sides, so we get 5 equals b. Okay, I know I boxed it, sorry. We're not done. We've got b here, so we have m, we have b, so let's write our equation of the function. So it'd be y equals negative 2x plus 5. Okay, so that is it for our 1.2.3 notes. Thanks for watching.